Welcome to another coding tutorial, and in today's video, I'm going to show you how we can make this oscillating T letter. The letter T is composed of two lines. Let's focus on the bottom part of the T. This first line is going to be moving in a circular path at a specific radius from the center point and at a specific angle. So let's start by declaring these two variables. The first one is radius r. Let's set it to, how about 100? And then let's start the angle at 0. To draw on the canvas, we actually need Cartesian coordinates of x and y instead of r and angle, and we can do that easily by using two equations. Let x equals to r times cosine of angle, and let y equals to r times sine of angle. This is how we convert from polar coordinates to Cartesian coordinates, and I have a whole video that explains the details of this, so if you want to get a better understanding, I recommend you watch that video. Now we're going to use the function called line to draw this bottom part of the T. And line takes in a total of 4 arguments, the x and y coordinates of the 2 points. So the first point is going to be the point of origin, and then the second point is going to be the x and y coordinates that we just converted from polar coordinates to Cartesian coordinates. All right, let's try this. As you can see here, because our origin point is still at the bottom left corner of the canvas, you can't really see the line. So let us use the function called translate to translate the origin point to the middle of the canvas. So at angle equals to 0, the line is horizontal. It's not moving, and we can move the line very easily by incrementing the angle variable by 1 degree. And because I'm using the degree mode, I need to set the angle mode to degrees. All right, so now our line is moving in a clockwise direction. Now let's focus on the other line that makes up the letter T. This line is going to be perpendicular to the bottom part of the T, and is tangent to the second point, x, y. Because the length of these two sides are equal, we know that the x and y distance here are also equal. Let's call it xt and yt. And so the points will be x plus xt, y minus yt, and x minus xt, y plus yt. To figure out the length of xt and yt, we need to use trigonometry. To do that, we need to know what this new angle is. Let's call it angle t. So now, just to not be confused, we have angle t here and then angle. We can calculate angle t based on the known angle, which is the angle measured in a clockwise direction from the x-axis. Let's draw a line here. Because these two lines are perpendicular to each other, we know that the sum of these two angles is 90 degrees. So this angle is 90 minus the variable angle. The sum of all the angles in a triangle is 180 degrees. So we know that this angle is equals to the variable angle, or 180 minus 90 minus the variable angle minus 90. These two lines are also perpendicular, so the sum of these two angles is 90 degrees. And now we know that angle t must be 90 minus the variable angle. With what we just discussed, let's declare more variables. So first, rt, let's set that to 30. Angle t, let's set that to 0. And then inside the draw function, first let's calculate the new angle t. So angle t will be equals to 90 minus angle. And then we're going to declare more variables. So let xt to be equals to rt times cosine of angle t. Then let yt equals to rt times sine of angle t. And then we're going to draw this other line. So it's going to go from x, right? X minus xt, y plus yt. And then the other point would be x plus xt and y minus yt. And the angle is going to be incrementing by 1. And then now we have a letter T that moves in a circular motion. All right, so once we have this, we're going to put this code in a class. Come here, then we're going to click plus sign. I'm going to add a new file. I'm going to call this file letter.js. And then before we write anything, let's go to index.html file. Then come down here, copy this line of code, and then change the name to the name of the new file that we just created, which is letter. And this is a way for us to integrate this new JavaScript file into our program. So once we have this, we can go back to letter.js. Then I'm gonna write a class, and this class, I'm gonna call it letter. Inside the constructor function, we're gonna put in 2 arguments, so radius and angle. So this dot r equals to r, and then this dot angle equals to angle. And then I'm going to create a method called display. And then let's go back to our code here. We're going to copy this line of code. All right. So we're going to translate it to a specific point, right? So right now we have it at width divided by 2 and height divided by 2, which is the origin. So how about we add 2 more arguments and we call this OX and OY for origin X and origin Y. So then we need to also declare new variables here. All right. Okay, so inside this translate function, we want to put the OX and OY, right? And then now we need to tweak this piece of code a little bit. All right, so angle T will be equals to 90 minus this dot angle. And then we need to put in this dot in here, this dot here, this dot here, this dot here, 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 and here. Okay, so once we have this, let's go to sketch.js and try to just create one object. So let me delete all of this. Let letter equals to new letter objects, right? And we have a total of how many arguments here? 4 arguments, right? The X and Y location of the origin, then the radius and the angle. So we want to put width divided by 2 and height divided by 2, and then the radius, let's set it to 100 and angle at 0. So we're just drawing the same exact thing, but now we're creating an object. Then we can delete this, and then we can just do letter.display to call the method. All right, we cannot see the top part of the T. Let's go back to letter.js. Oh, right now this .rt is not declared, so this .rt is going to be, how about we just set it to be 1/3 of the radius of the bottom part. All right, okay, so now that that's working, let's create a bunch of objects. So let's go back to sketch.js. Instead of just a variable called letter, let's do letters and set it equals to an array. And then we need to create a few more variables. So columns, rows, and size. And I'm going to set size to 20. And then I'm going to create a 2D array called letters. And I need to use a nested for loop to do that. So for let I equals to 0, I less than columns, right? I plus plus. And then for let j equals to 0, j less than rows, j plus plus. All right, before I move forward, let's also calculate what columns and rows are going to be. So columns is going to be width divided by size, and rows is going to be height divided by size. And then inside the outer loop, we need to first fill in this letter arrays with a bunch of empty 1D arrays. And then inside the inner loop, that's where we're going to create a bunch of objects. So we're going to use the same syntax here. We can copy this, and I'm going to delete this. All right, but we don't want to set it at all at width divided by 2 and height divided by 2. We want to set it at each of the cells inside this grid. So I times size and j times size. And we want the size to be not 100, but size. And let's set the angle to be 0. If we click play now, nothing happens because we have not called the display function. So we need to also delete this, and we also need to use a nested for loop to call all of the objects that we just created. And now to call the display method, we need to get each of the object inside this 2D array, right? And then dot display and click play. Okay, so the reason that it's all in here instead of in each of the cells along this columns and rows is because we forgot two key functions when we do transformation. So let's go back to letter.js. Inside display, we need to use the function called push and pop. And these two functions, push saves the transformation state. So right now it translates to each of these points, right? So at the origin point, OX and OY. But once it saves this and does all of these transformation here, we need to put in the pop function so that it returns back to the original state before it gets called again for the next letter T. All right. Right now, we're moving the letter T in a constant speed along the circular path by incrementing the angle by 1 degree at a time. But we actually want to move it in an oscillating motion. So let's first create a new method called move. And I'm going to move this line of code here inside the move function. Instead of putting in a constant speed of 1 degree, I'm going to move it in an oscillating pattern. And to do that, we need to use a simple harmonic motion equation. Simple harmonic motion is a type of oscillation, but the special thing about it is that it can be represented by the sine or the cosine function, and it has an output between -1 and 1. That's why we can see the oscillating motion back and forth, because we want to change the angle. Instead of at a constant speed of 1, we're going to give it this output that we get from the sine or the cosine function that would go back and forth between -1 and 1. So let's first create a new variable called increment, and I'm going to set this increment to, let's do a sine function, and the argument will be t. And then let's declare a new variable called t, set it to 0. So this would be this.t. And then this.t is going to be increment at a speed of 1. But then now, instead of putting 1 here, we're going to change it by the increment. So how this works is that we're going to increment this.t by 1 each time, and sine of this.t is going to range between -1 and 1. And then this output is going to be put as an increment that changed the angle of each of the letter t to get that oscillating motion. And then let's go back to sketch. Now we also have to call letters of I and j dot move. Okay, so now you can see that it's moving in an oscillating motion now, but it's only moving kind of slightly. So if you want a greater amplitude, or if you want it to move at a greater extent, all you need to do is that you need to change the amplitude. Right now the amplitude is just 1, right? So we will multiply the sine function by 1. So we can change that. Let's do 5. All right, so you can see that it's moving at a greater extent now and at a bigger, larger degree. Let's go back to sketch, and I want to tweak this line of code a little bit and give it an offset of size divided by 2 here and size divided by 2 here, such that the origin point is shifted a little bit to the middle. All right, so instead of having it at the top left corner of each of the cell, we move it by size divided by 2 to the right and down. And right now my t is a little bit too long, so I want to also create an offset. So I'm going to set offset to be equals to 2/5 of the size. And instead of just putting size here, I'm going to minus it by offset. Okay, that's better. All right, and then I want the size to be just 10. Now to the last part, we want to separate our image or our canvas to be the background and the letter T. We're going to do it by importing an image into our sketch, and that image has the letter T, and then we're going to figure out which part of our sketch is part of the T and which part is part of the background. And then we're going to set the angle at which we rotate the letter T based on which section it's in. So first, let's come here and then click plus and then click create folder. I'm going to call this folder images. And then you're going to click this arrow and then upload file. And then this is where you're going to drag and drop your letter T file. Once your image is uploaded, then you want to create a new variable. I'm going to call it img for image. Then we're going to use a function called preload. and preload is going to preload the image into our sketch. I'm going to set the variable img to another function called loadImage. Inside this parentheses, we're going to tell the computer where our image is. And in my case, it's in the folder called images, and the file is called t.png. So inside this parentheses, I also need a quotation mark, then the folder name images, backslash, and the name of the file, so t.png. I'm going to run it. It's uploaded successfully. And now let me show you what the image looks like. So I'm going to come here and use the function called image, and then image takes in a total of 3 arguments, so the name of the file, and then the x and y coordinates of where I want to place the top left corner of my image. So let's put it at the top left corner of the canvas. All right, so this is the letter T. So because my image is of the same size of the canvas, I don't need to resize or anything like that, but you can use another function called resize. You need to put the name of your file, so img, and then dot, and then the function called resize. And you can put in 2 arguments here. So the first argument is what is the width that you want it to be. So right now the canvas size is 400. So let's say I want it to be half of this size. So let's do 200. And then I want the height to be, let's do, how about 100? So as you can see here, now it's of the size 200 by 100. But if you put in the second argument at 0, it's going to resize your image proportionately to what the original size of your image is. Okay, so I don't need any of this. So I want the size to be of the size of my canvas, and I don't actually need to display the image anymore. Next, we're going to use a get function to get the color value of a specific pixel. So inside the inner loop here, I'm going to declare a new variable. Let's call it C, and C for color, right? So C is going to be set to the get function. So to use the get function, we need to also put what image we want to get the color value from. So our file is called img, then we put dot, and then the function called get. And then we need to put in 2 arguments, the x and y coordinates of the pixel that we want to get the color value. So we're going to get the color value at I times size and j times size, because we want the color values of each of the cells in this grid. So actually, let's also print what C is. So you can see here, because our image is black and white, right? So you can see that the values are either 255, 255, 255, which is white, or 000, which is black. Okay, but instead of just taking the color value, I actually just want to get the brightness value. So let's put in brightness here. So brightness returns a brightness value of that specific pixel. So let's print this. So brightness is between 0 and 100, 100 being white and 0 being black. So because our image is just black and white, we could actually just use the color value here. But I'm just showing you that we can use the brightness function if you were to have, let's say, like a color image. So now I want to write a conditional statement. And the conditional statement is going to ask if brightness of C is, if it's 0, which is black, right? I want to set this new variable called isLetter to be true. And we also need to create a new variable, which I already did. Let isLetter, and else set isLetter to be false. So isLetter is a Boolean variable that returns either true or false. And we want to do this such that we can put it as a new parameter within our class, or the object letter is letter. And now we have to go back to our letter class and add a new argument here, is letter, and then also set this dot is letter to be equals to this. All right, and then let's just click play. Okay, no errors. And now I want to show you in the display function. So I'm gonna write a conditional statement that says if this dot is letter is true, then set the stroke color to be red. Else, set the stroke color to be black. Okay, so now you can see that we have our letter T here based on the brightness value that we extracted initially. All right. But actually what we want to do is that we want to change this dot angle based on if it's part of the letter T or not. So instead of writing the conditional statement here, I actually want to write the conditional statement here. So if is this dot is letter is true, then I want this dot angle to be initialized at -90, and else I want it to be at this dot angle here. And I'm going to delete this part. And then this dot letter needs to be declared before this conditional statement. Okay, let's click play. All right, so now you can see that we can distinguish between the T part and then the background part. But now we also need to change the angle of the background part. Right now it's moving at the same angle. We want to move it in a wavy pattern. And we can do that by, let's go back to Sketch, changing this variable here. So we want to change it to I times size plus J times size. This is going to give it that wavy pattern. So let's click play. Ta-da! All right, that's pretty cool. And now all you have to do is change the colors. So let's change the background to, how about black? And then let's change the stroke color to white. Perfect. It's so cool that we can make this interesting kinetic typography based on just a few concepts that we have already learned. If you have a suggestion of a tutorial that you want me to do, please leave it in the comments. Give this one a try.